All right, so what we have here are two similar prisms, and it says that the volume of prism A is 4,320 centimeters cubed. We don't know the volume of prism B, and that's what we're going to find. The only thing that we know is the ratio of their side lengths, and it's 12 to 6. So let's look at this new to old, because that's how we find the scale factor, remember, new to old. So that's that 6 to 12 ratio, or how we've been writing it, is 6 over 12. That, if we simplify it, is 1/2. That's your scale factor. New to old, scale factor, 1/2. But we don't really need to know the ratio of the side lengths. We need to know the ratio of the volumes. That's how we're going to find the volume of the smaller prism. So if we want to find that, we need to not square the scale factor. That would be for areas. We're dealing with volumes. We need to cube the scale factor. Go one step further. 1/2 times 1/2 times 1/2. So 1/2 times itself 3 times. You can put it in your calculator or just multiply it out in your head. It looks like this. Straight across on the top gives you 1 still. And then straight across on the bottom, 2 times 2 times 2 gives you 8. 1 over 8. So the ratio of the volumes is, instead of being 1 to 2 or 6 to 12, it's 1 to 8. 1 over 8. So if I wanted to find the volume of the smaller prism, I would multiply, or excuse me, well, it depends how you want to look at it. I would multiply this times 1/8 to get the new one, or you could just divide it by 8. And that will actually give you the volume of the new prism. And that would be 540. So all we did, and I wrote this wrong here, that was cubed, and this should be cubed as well because it's volume. All we had to do was take this, find the scale factor of the lengths, and then cube it because we're dealing with volumes. If you're not sure what I'm talking about there, make sure you watch the lesson from 2.09 and 2.10. Here's two similar cylinders. The volume of the larger cylinder is 343 feet cubed. The volume of the smaller cylinder is 125 feet cubed. So here's your larger one. Here's your smaller one. And then it says the height of the smaller one is 5. We don't know the height of the larger one. In order to find the height of that larger one, we need to know the scale factor. But here's the problem. All we know is the ratio of the volumes. We know 343 to 125, which we can write as 343 over 125. If that's the ratio of the volumes, then we need to take the cube root of each of those in order to find the ratio of the lengths. Again, if you're confused on this, watch that recording from lesson 2.09 and 2.10. But the cube root of 343 is just 7. The cube root of 125 is just 5. So the ratio of their lengths is going to be 7 over 5. Larger over smaller here. So if I wanted to find the larger one, look at this, it answered it for us because we would set up a proportion. This is the scale factor. We would just set up a proportion to solve for the larger one. Smaller is on bottom. Well, if the smaller one's 5, we were going to solve for x, but it has to be 7 in order for these two to be equal. So x is 7, and we're done. The height of that larger cylinder is going to be 7. A rectangle now has a width of 8 meters and a length of 7. how does the area change when each dimension is multiplied by 5? So we're thinking, and you can work this whole thing out, but the great thing here is by our shortcuts, we don't have to. The new dimensions would be 35 by 40. And so you can work this whole thing out, but by what we've talked about with the ratios of the area compared to the ratio of the scale factor, we know that the scale factor here is 5. That's what that's telling us. The ratio of the areas then is just the scale factor squared, because the scale factor is for lengths or perimeter. The scale factor squared is for area. So the area will be multiplied by 25 instead of multiplied by 5. So it would increase 25-fold.